it asks you to talk about to sketch a new picture, and this is an enlargement, and you're moving the graph also. And to talk about, for excellence, you need to comment on the relationship between the size of the bridge and the equation that models it. So can you come up with some kind of generalization? Let's take a closer. Here I've drawn another bridge. We need one that spans two places of the river, but still has a height of 2 squares. So I've still got 2 squares there, but my vertex has moved, so I can write the equation for my new vertex. So I've got y equals an a, x, it's from the 0, my new equation, it's moved to the right 1x minus 1 squared, and it's moved up to 7. So that's the equation. I need to find out what a is. Now we've got, again, take a point. I like the point 5, 6. So if I put 5, 6 in the equation, remembering that's my x, that's my y, use equation solver. So I've got 6 equals a, and 5 minus 1 squared plus 7. In equation solver, execute, and I find out that my new a is -1/16. Now previously, in my previous equation, my coefficient a was 1/4, -1/4. So by I've actually made it twice as wide. This graph was 6 squares wide. This is now 12 squares wide. By enlarging it, I've actually just widened it by a scale factor of 2, but I've kept the same height. So from -1/4, it's gone to -1/16. So that's a quadratic relationship. It's been squared. 4 has been squared to become 16. Now we'll take another look at an enlargement. This time an enlargement here where I've enlarged the whole graph. We haven't kept the height as 2. So from the centre of the parabola here, I've enlarged it by a scale factor of 2. In the black, I have my original equation for that graph. And now if I look at the equation for my new one, I'll take the point 9, 2 to work out the equation. So my x is 9, my y is 2. Put it in equation solver. So I've got y equals a, this was x minus 5 squared plus 4 for the light blue graph, and I'll put 9 and 2 in, so 2 equals a 9 minus 5 squared plus 4. So I now know, if I do that in equation solver, that a equals 1/8, -1/8. So what I can see from this graph is when I have enlarged it by a scale factor, my scale factor is 2, my coefficient has gone from -1/2 to -1/4. So I have an inverse relationship. Now you need to try this on other graphs. This is for excellence. I have an inverse relationship between my scale factor and my coefficient. This is my scale factor was 2, and my coefficient here ended up being from going from -1/2 to -1/4. So it's an inverse relationship. Have a look at some other graphs. Have a look at your absolute graph. What happens when you enlarge it by 2? Does the coefficient end up being halved? So you're multiplying one by 2 and then the other becomes halved. Check that out. And that's probably enough on this one. Thanks. Bye-bye.